We're going to be taking a look at the distributive property today. We have an objective that says I could use the distributive property to solve multi-step equations. We're going to get to the multi-step equations part later. Today we're just practicing the distributive property on its own. We got a couple of vocabulary terms. The first one there says to multiply a sum by a number, multiply each addend by the number outside the parentheses. This is the distributive property, and this will make a little more sense later. We might even come back to this definition and talk about it once we've had a chance to look at the distributive property and what it looks like in action. The second one says the expression or expressions, that have the same value. Those are equivalent expressions. And we got this introductory problem here. It says Jordan buys 3 notebooks that cost $5 each and 3 packages of pens for $6 each. How much money does Jordan spend? And it says show in 2 ways. So because she buys 3 of each, we can set this expression up like this. 3 times 5 plus 6. So traditional order of operations says that we can go ahead and just add what's in parentheses. We should go ahead and do what's in parentheses first. So we'd rewrite this as 3 times 5 plus 6 is 11 because she's buying 3 of each. We can add the 5 and the $6 together and then just take 3 times the 11 there and she spends $33. So that's one way to do that, but it says to show in 2 ways. So rewrite this 3 times 5 plus 6. And the distributive property says that instead of having to multiply the 5 plus the 6, since they're going to get multiplied by 3 in the end anyway, we can take 3 times each one of these separately and then add them together. We could multiply the sum, this 5 and 6, by the number, multiply each addend here, the 5 and the 6, by the number outside the parentheses. So 3 times 5 and 3 times 6. So 3 times 5, and we could literally write this out kind of step by step. 3 times 5 plus, since there's a plus on there, 3 times 6. 3 times 5 is 15. 3 plus 6 is 18. And 15 plus 18 is 33. And you might say, well, that seems like more work. Why would we want to do that? And you're going to see here in a little bit that there are some situations where we have to do the distributive property to be able to simplify some expressions. So yeah, this may seem like more work at this point, but in the end, it's going to be really helpful for us in some situations to know how to do that. This is basically what we had for our vocabulary term, to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside parentheses. And it shows us here with symbols how that works, A times B and A times C, and then with numbers how that works, 4 times 6 and 4 times 2. You can do that, multiply that number outside the parentheses times each thing inside parentheses. Let's get to our steps here. It says use the distributive property to evaluate the expression. So I want you to rewrite here for step number 1 what we have. It says multiply the number outside parentheses by the first number in parentheses. So first of all, we're just going to take the 7 times the 8. And we could rewrite 7 times 8 down here, but another way to do this is just to go ahead and do the mental math there. 7 times 8 is 56. So we're going to go ahead and copy this down, what we have so far. Then it says to write the operation between the 2 numbers here. We have subtraction going on. We're actually, when we get into this, we're just going to include this sign in the multiplication here. So we're actually going to go down to step number 3 here and multiply the number outside the parentheses by the second number in parentheses, and we're just going to include the sign in front of numbers when we do that multiplication. So instead of bringing down this minus sign and then multiplying, take 7 times -5, and that will give you -35. And that'll still be treated as a minus sign there, but that's going to save us a step when we do these. So we're just going to do 56 minus 35 there. And then it says we're supposed to evaluate the expression here, so we have to go and figure out what that equals. 56 minus 35 is 21. So that's our final answer there. But you have to do that using the distributive property. Go ahead and flip over to the back side. We got some together problems we're going to do here on the video before we do some problems on your own. You guys come to class. So taking a look at is on the back. It says use the distributive property to evaluate each expression. This is 8, and then parentheses 9 plus 4. All right, so to do the distributive property, we take the 8 times the 9, and then the 8 times the 4, and then add them together. So 8 times 9 is 72. And then 8 times positive 4, we'll include this sign, is positive. Since we have to write some operation here, we'll write plus 32. So we add that together, 72 plus 32 is 104. Okay, so that's our final answer there, but we have to show that we did it with distributive property. Number 2 is in parentheses 12 minus 7, and then you've got the 9 on this side of the parentheses. So it doesn't matter if the number outside the parentheses is on the left side or on the right side. You're still going to take that number outside parentheses and you're going to keep these in order. So if you multiply it times this first, that's fine, you just got to bring it straight down. Or you can multiply by this first and bring it straight down. I like to go ahead and multiply, start on the left and multiply over here first. So 9 times 12 is 108. And then 9 times, and we're going to include this sign in our multiplication, 9 times negative 7 is negative 63. And then we just subtract 108 minus 63 gives us 45. So you're going to have a section on your assignment where you're using distributive property to evaluate those expressions. But let's go ahead and do these next ones. We're going to skip number 3 because these are a little more going to be geared towards what we're going to be working on eventually when we solve equations with these. So it says use the distributive property to rewrite each expression. Notice it doesn't say to evaluate because we won't be able to evaluate these. They're going to have some variables in them. So number 4 is 6, and then in parentheses a plus 4. That's an a right there. That's our variable. So it's important to be able to do distributive property because in this case we can't add a plus 4 because we don't know what a is. So we can't do order of operations the normal way that we would do that. We can't do what's in parentheses, but we can still eliminate the parentheses by using the distributive property. So it doesn't really matter what a plus 4 is, we can still get rid of these by taking 6 times the a and 6 times the 4. So any number times just a variable by itself, remember this would count as 1a. So you can think of this as 6 times 1 with the a attached to it. But usually we just go ahead and say 6 times a is 6a. Okay, so they do get attached there to show multiplication. And then 6 times 4 is 24. So these are 6 times a plus 4 and 6a plus 24. This is just a little simpler. In fact, this is what we call simplest form because we can't add the 6a plus 24 because they aren't like terms. We're going to talk more about that in a future lesson. But in order for them to be added together, they have to have the same variables or neither one of them have a variable to be added. So this has an a and this one doesn't, so they can't be added. These are equivalent expressions, like we had for a vocabulary term here. But this is the simplest form here for this because we've gotten rid of our parentheses, but that's all the further we can do with that. Let's do another one here with number 5. It's negative 2 on the outside parentheses, and in parentheses, x minus 8. So we're going to take this negative 2 and distribute it out to both the x and the negative 8. So first of all, negative 2 times x is negative 2x, and then negative 2 times negative 8. Think about that for just a minute. It's a negative times a negative, so it's going to give you positive 16. So negative 2x plus 16 is what we're looking for on that one. All right, number 6. We have y plus 10, and on the outside of parentheses, in its own set of parentheses, a negative number. And it's important that the parentheses is there to show that this is getting multiplied. This isn't just a minus 3 at the end. If we didn't have the parentheses there, it would be y plus 10 and then subtract 3. But this is being multiplied times what's inside the parentheses. So we're going to take the negative 3 and multiply it times both things. I like to start and go straight over to the left. You can, again, you can multiply times this thing first if you want to, but just bring it straight down. You don't want to reverse the order here. So negative 3 times y is negative 3y. And negative 3 times positive 10, negative times a positive will give you a negative, and 3 times 10 is 30. So negative 3y plus 30 is what you get there. Okay, we're on to number 7, the last one here. This one's going to challenge you a little bit here. It's going to be 5x on the outside, and then 3 minus 4y there. So this time we have to take the 5 and the x and multiply it times each thing inside parentheses. So 5x times 3. If you have some numbers, some regular numbers and some letters, focus on the regular numbers first. 5 times 3 is 15. And then any letters that are in there as well are going to get attached because they're still being multiplied times this as well. So 5 times 3 is 15, and this is also an x that it's being multiplied times this as well, so it's 15x. Then you're going to take the 5x times the negative 4y. Again, focus on the regular numbers first. 5 times negative 4. 5 times negative 4 is negative 20. And then we have more than one letter, so this is they're all being multiplied here, so that we have to include both of them. So we want to put them in alphabetical order. X comes before y, so it's between x and y. So any letters that are included in the multiplication in either this number or that number get included in the answer there as well. So 15x minus 20xy. And these are still not like terms. They both do have an x, but this one has a y and this one doesn't. If this one also had a y, we could go ahead and subtract, but they're not like terms. This is the simplest form for this one also. All right, we're going to do a little more with distributive property in class, but that's it for now. I'll see you guys in class.